Hello everybody, so I'm here to mark the exam with you. There are going to be two parts to this video. Obviously this is part one. Okay, so let's get started. So there are four types of pathogen. The four types of pathogen are fungi, protists, then viruses and bacteria. And the ones that make us feel ill through producing toxins are bacteria. The ones that live and reproduce inside cells are viruses. The type of cells that defends our body against pathogens are white blood cells. Not to be confused with red blood cells. Red blood cells transport oxygen around the body. White blood cells defend our bodies against pathogens. There are three ways in which white blood cells do this. You can remember that with the mnemonic P-PAPA, and that stands for phagocytosis, produce antibodies and produce antitoxins. So let's write that in: phagocytosis, produce antibodies and produce antitoxins. Phagocytosis is a process by which a pathogen is consumed. So if that's our pathogen, the white blood cell will actually change shape and consume that pathogen. So that's the white blood cell. It will then digest the pathogen and destroy it. Antibodies, we'll talk about them in a moment. Antitoxins, they're there to neutralize toxins produced by things like bacteria. Okay, so just moving down. The name given to the proteins on the surface of a pathogen, those are called antigens. I'll show you exactly what that is. So every pathogen has unique antigens. We'll talk about that more in a moment as well. And the antigens are on the surface of the pathogen. Right, so that's pathogen 1. Another pathogen, call it pathogen 2. It's going to have different antigens, so they might look a bit more like that. Pathogen 3 might have different antigens. 4 will have different antigens. 4 will have different antigens. 5 will have different antigens. Every different pathogen has different antigens, and so the white blood cell needs to make a new antibody every time. So an antibody to fit this pathogen would look like this. An antibody to fit this antigen would look like this. So this is your antibody, and then those antibodies are able to destroy the pathogens by locking onto them and destroying them. Okay, so that leads us on nicely to the next answer. So the reason the body must develop immunity to each different pathogen is because each pathogen has unique antigens on its surface, and white blood cells must make specific antibodies to fit them. Okay, next question. Measles is a serious illness that can be fatal. The reason it cannot be treated by antibiotics is because antibiotics are there to treat bacteria. Measles is a virus. The symptom of measles is either fever, or you could write a red skin rash. Going down to look at the graph, we've got the year on the x-axis, the number of deaths on the y-axis, and it wants to know the number of children under 5 that died in 1985. Here's 1984, there's 1986, 1985 is in the middle. If you go up and across, you can see that it goes to 7 there on the y-axis, so the answer would be 7. 2D, the reason is that they are vaccinated when they are babies, so that's why we've seen a big decrease in the amount of children dying of measles. If they get vaccinated, they are very unlikely to catch it when they are older. Okay, question 3, let's fire through this one. So polio, it's caused by a virus. Children are given the vaccine to protect them against this. It's difficult to kill the polio virus inside the body because it lives inside cells, as all viruses do. Vaccines contain inactive forms of the polio virus, and the point in giving somebody these inactive forms is that their body is able to produce antibodies to destroy the virus, and then it remembers how to make those antibodies for the next time it encounters the polio virus, and obviously that's a good thing because you can destroy the polio virus very, very quickly the second time. Alright, so we've got another lovely graph here. Year on the X, number of polio cases on the Y. The first question asks us, in which year was the number of polio cases the highest? That, as we can see, well, look, here's the highest number of cases. It's the peak in the graph. It's quite helpful to use a ruler here, just to go down and see what year that was. So let's make a little mark. We've got 1948 there, 1953 there. There are 10 little squares in between. This one goes 4 along. 1, 2, 3, 4. It's actually 1, 2, 3. Yeah, it's 4 squares along. Every 2 squares, so it's 4 squares. Every 2 squares equals 1 year. So if it's 4 squares, it's 2 years. So this would be 1950, 4 squares along. Okay, 1950. So the polio vaccination was first used in 1955. How many years did it take to fall to 0? So it was first used in 1955, which was let me just find it, because that's 1954, 1955. So it was first used here. It got to 0 in 1963. So the difference between that and that is 8 years. So it took 8 years to fall to 0. That's the answer there. And there have been no cases, but children are still vaccinated. The reason for that, the most obvious reason, is it could be reintroduced. Maybe from abroad. Okay, you could also say the disease might spread if it came back. You also say to offer protection on holiday, things along those lines. Okay, that's the end of part 1.